Hello everyone, I am Sarita Pradhan, pursuing my PhD from IIT Kharagpur. Today I am going to show how to model and simulate a hot rolling process having two stages of thickness reduction. So here we can see the schematic of the process in which we have several stages, but we are going to um, model only up to two stages of the rolling. So up to two stages it will consist of two rollers and two descaler units. So here in the screen we can see the inputs that we are going to provide to the software, so that it can provide us with the result and we can analyze the result. So for that I am going to create uh, models for which I have to open Abacus, and from starting from the descaler unit, here we have to draw the parts in the part module. I have created a descaler unit for this. Then I have created the roller 1 for the first stage of thickness reduction, then roller 2 for second stage of thickness reduction, and for stock material that is going for the thickness reduction. So here I have provided this type of edge for, so that it will be it can easily move inside the roller, and proper biting will happen. So after creating my parts, I have to go for tools. Then I have to select create reference point. So there is no need to create reference point on the stock, so I have created reference point on the stock, descaler, roller in the center of the roller, and roller 2 also. So these points are provided in order to put some boundary conditions over the parts. So after the part has been created, several parts, we have to go to the property module to assign the properties to each of the part. So in the property module, I have created two material property, that is for roller material and for stock material. For roller material, here you can see as per the data that we have been provided, I have put the values for which I have taken the conductivity as a density, elastic properties, and specific heat. So after creating roll material, we have to create the stock material property. So here we have given conductivity, density, elastic properties, then expansion coefficient, inelastic heat fraction, then plastic properties, and specific heat. So there is no need to create another material for the descaler. We are going to provide the properties of the stock material to the descaler unit. So in the property module, we have to go for the section manager. Then we will create three sections, in which there will be a descaler section, has a solid homogeneous, roller section, and stock section. Then after that we have to assign the particular section to the parts one by one. So after giving properties and assigning properties, we have to go for the assembly module. So as by following the schematic that has been provided, uh, we have to place each and every parts in the proper locations. So for that we have to use the translate option over here. So by using this, we can choose any particular instance and place them in a particular location with respect to the origin. So after placing each and every part, we have to go for the step module, in which we will decide that how many steps we are going to perform the operation. So here, as you can see, I have provided 4 steps in which the process will be done. So in the first step, the stock will go from the furnace to the roller 1. Then biting will happen in the rolling stage 1, that will take only 2 seconds, and from roller 1 to roller 2 it will take 3.85 seconds, and from roller uh, 2 stage reduction it will take 2 seconds. So these things has been calculated by using the velocity of the stock and the distance between the two instances that will be given in the problem. itself. So after that, we have to create a field output request for which we have to go. We don't have to do much things over here. We just have to include the things that we want in our results, for which we have to go for reaction moments and reaction forces and moments. So after that, we have to increase the interval up to 2000, so that it can capture all possible datas. And after creating field output in the step manager, we have to create a history output. For history output, uh, we are going to save the energy, uh, all energy totals. After doing all these things in the step module, we have to go for the interaction module, where we will provide the all possible interaction between two bodies. For example, there will be interaction between roller and stock, discolor and stock. Roller, for each parts we have to create properties. So for which I have created a roller stock interaction, roller stock interaction to stock, then stock discolor interaction to. After creating this kind of interaction, we have to also uh, put the values of roller radiation, radiation values and convection values, because these things are provided in the interaction manager itself. So we can see, for roller convection, we can see I have provided the value of film coefficient of 0.085, and the skin temperature, that is the ambient temperature, will be 40 degree. So these things are will be provided in the problem itself. So here we can put our values, and we can create as many interaction as we have in the geometry. So after creating interaction, we have to go for discolor stock interaction property. So here we know that property which will be type of contact property, the discolor unit will touch the stock, and the roller also touch the uh, um, stock. So here in between the roller and stock, there will be a friction coefficient, and that value is given as 0.25. After that, there will be some rigid body constraints we have to provide, because in the initial step where we when we were creating the parts, the roller and the descaler unit were chosen to be deformable bodies. So we have to give some kind of constraint so that it will not deform as the process follows. So we have to create some rigid body constraint over here, for which we have to choose each and every body as a rigid body. Then after creating each and every interaction, we have to go for the load module. In the load module, what will happen, we can provide the natural boundary condition, and we can provide the essential boundary conditions. So for in since we are going to provide boundary conditions, means how we are going to, how the parts or the instances are going to move or place them in the model process, we are going to decide. So for that, we have to encaster the discaler unit, means we do not want our discaler unit to move anyway. We will discaler temperature will we will give. Then we have to log the roller translational velocity. We have to log we have to only provide the roller angular velocity, and we have to also look for the stock symmetry conditions. Means there will be no material movement along the along the direction perpendicular to the symmetry plane. So these many boundary conditions we have to create. So after successfully creating the boundary condition, we can uh, give values of initial values in the predefined field manager, in which we have to provide the initial stock velocity, roller initial temperature, and stock initial temperature. So as we can see, in the initial stock velocity, we have provided it 1000 millimeter per second. In roller temperature, initial roller temperature, we can see the temperature is given as 70 degree centigrade. So in this way we have to create each and every thing, or each and every step in the process. So after successfully putting all the values in the load module, we will go for the mesh module, in which we will do the meshing of the parts by using the mesh by part option. So here I have meshed the discaler unit first, then I have provided the mesh to the roller. Then for roller 1 and roller 2, the mesh is the same, and then we will go for the stock meshing. So for that, for meshing the parts, we have to go to the mesh controls, and here we can see that element type is quadrilateral structured. Then we have to do the things. Then we have to go for the element type, in which we can see, we can choose the instance, and we can know, we can assign the element type, which type of element we do want to select. Then after that we have to go for the shading option. Here I have done the shade by edges, so we can shade the edge, and we can give the number of elements that we want to place over here, or the place over this particular length. So after meshing all the parts individually, we can go for job module, where we have to create a job. So in job module, job creation is done. So here I have created a job, here I have named this as assignment take 4. So here we can see that in the job module we don't have to do much more over here. So here we have to go to the parallelization, and we have to use multiple processor up to 4, because it will accelerate the simulation, and we will get a result faster. We don't need to do these things. If we will not do anything, then the process will take some time to run. So in this way we can create a job, then we have to submit, and we can as well as monitor the job. So after doing all these things, uh, we can visualize our result. Means I have already done the process, and I have already done the simulation. So to properly visualize the process, that how it is going, and how the results are coming, we have to open the ODB file. After the run, bakers will generate a ODB file for that particular job. So we have to create open in the next step, and we have to see that how it is going to happen. So you can see this is our stock, this is our discaler unit 1, this is roller 1, this is discaler unit 2, this is roller 2. So with this we have showing in the undeformed shape. So when we go for the deformed shape, we can see the stock is moving from this to this particular length. And here if we'll take the frame selector, we can easily see how it is going to move in the space. So here we can say, see, there will be less reduction in the second stage. So we can go for the first stage reduction, so that it will be easy for us to see how the reduction is, thickness reduction is happening over here. So as the time progress, the thickness reduction is happening from initial thickness, stock thickness of 57 millimeter to final of 22 in the first stage. So here we can easily plot the graphs, the related the information that we want to extract from the particular model, we will get over here. So I can show you one how to plot graphs. So for which we have to go for create XY data, for which we have to go for tools, XY data manager. So here we have to create, you want to create ODB field output. So here we can select the unique nodal. So here I am going to show our reaction force along 2, means along y direction. So we have to choose the element. So I am going to check reaction force for roller 2. One node is selected, means for roller 1, sorry, for roller 1, how much reaction roll separating force it will experience. So now for plot to plot the graphs, we have to wait for some time. So finally we can see the graph between the time and the rule separating force. It is in minus because it will be a compressive load, so the value will be minus. So in this way we can get the graphs. And as we can see that I have modeled the part only halfway, because it is a plane stress problem. So we can use it as a 2D problem, and then we can create the whole model by simply just go for the mirroring options. So for that we have to go for ODB display options, in which we have to go for, first we have to create our coordinate system, for which I have to select coordinate system. I have to create my own coordinate system, for which I will take this as origin. This will be my x-axis. This will be origin. Then this will be in the x-axis, and this will be in the y-axis. So I have created one coordinate system. Okay, so my plane has been all created. Now I will go for view, then ODB display option. Here I have to choose this one, then I will mirror everything on this plane, and now we can see the whole process or whole model over here. So by using this software we can easily find out the rule separating force, roll torque, and after getting roll torque we can compute the power requirement, and after um, getting the power we can know the what will be the rating of that particular setup. And from this software we can easily find out the temperatures on the layers, on each nodes, like we have to just select one particular node, and we can we will be it will be easy for us to find out the temperature. So in this way the simulation is performed. So thank you.